Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Thaqif and today our group will present about our final report project, physical security and electronic surveillance. And our group have 7 members. And I will present about introduction. Our project focused on designing a partial ESM architecture to understand how real-world system collect and analyze security logs. Why? Because cyber threat evolve daily and organization rely on ESM tools like CIEM to detect attack early, and we aim to simulate an ESM environment using tools like SolarWinds LEM. Integrate security agent like firewall IDS to monitor log. Test how log correlate to potential threats like failed login or disk overload. Tools and scope. We use a virtualized lab with Hyper-V for hosting VMs like our ESM client and server GNS3 to emulate network devices. Cisco router as log generator, and SolarWinds LEM as the CIEM platform to centralize log. We hit a snag the trial vision log, external log, but we still gain key insight into internal monitoring, which we will explain later. Next, I will pass to the next person. Thank you.
Hi, my name is Irfan Danish, and for our ESM implementation, our group chose to follow option A, which uses Hyper-V as the main virtualization platform. We designed a partial ESM architecture that includes three main components. Firstly is the ESM client. We use a Windows 7 virtual machine created in Hyper-V. Secondly, ESM server, the SolarWinds Log and Event Manager or LEM, also running in Hyper-V. And lastly, the agents, which is the Cisco router simulated in GNS3. All of these components are connected using a Hyper-V external virtual switch. This switch allows our virtual machine and GNS3 devices to communicate on the same network. The architecture allows the router to send syslog messages to the LEM server, while the Windows VM can monitor the logs using the LEM report console and web interface. For the tool use, we use about 6 tools, which is Hyper-V to run the Windows VM and LEM server, Windows 7 ISO used to create the ESM client VM, SolarWinds Log and Event Manager, which is LEM for collecting and analyzing logs, GNS3 to simulate the network environment and routers, Cisco routers, the agent that generate and forward logs, and lastly the PUTTY to configure and test connection on the routers. This setup helps us create a realistic and testable ESM architecture and supports log collection, monitoring, and simulated security responses in a virtual lab environment. Thank you.
So hi, I'm going to present about the comparison of the tools. So first we have Hyper-V. This is a virtualization platform by Microsoft that enables the creation and management of virtual machines on a single physical host. Its strengths include seamless integration with Windows, support for virtual machine snapshot, and live migration between hosts. However, it has some limitations such as limited Linux support and the requirement of a Windows-based host system. So next is the Windows 7 virtual machine. This serves as a client operating system capable of running administrative and monitoring applications. Its strengths lie in the user-friendly interface, broad software compatibility, and stability for legacy systems. The major downside is that it's an outdated OS, no longer receiving security updates, making it vulnerable in secure environments. Then there is SolarWinds Log and Event Manager, commonly known as LEM. LEM is SIEM, which is Security Information and Event Management. tool that provides a real-time log collection, analysis and correlation. It stands out with features like agent-based monitoring, centralized logging, and visual dashboards. However, it is resource intensive and comes with a high licensing cost, which may not be ideal for smaller networks. Following that is GNS3. GNS3 is a network simulation tool that enables the creation of complex virtual network topologies. It supports integration with real device images, allowing for realistic network behavior during simulations. While it offers powerful features, it can be heavy on system resources that is often challenging for beginners to learn. After that, we have Cisco iOS routers in GNS3. Um, these are virtual routers that run actual Cisco iOS software within the GNS3 environment. They provide a true command line interface and behave like real device, making them suitable for testing configurations and routing protocols. However, they require official iOS image file and a decent understanding of Cisco commands to operate effectively. Lastly, there is PuTTY. PuTTY is a terminal emulator that supports SSH, Telnet, and serial connection, making it useful for managing network devices. It's lightweight, simple, and quick to use, especially for command line access to routers and servers. Its main limitation is the basic user interface, lacking modern features like session saving or tabs, which can limit efficiency during frequent use. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So today I will be presenting about our pattern of log. In our ESM project using SolarWind SEM trial version, we focus on analyzing analyzing internal system since external log was not supported. So we identified four main type of log, which is the first one is internal system log. It captures action like command task or configuration change and usually marked as informational. They help track SEM internal process, and we will move on to the second type, which is service and process log. This include events such as service restart and the severity range from informational to warning, it depending on the system state. Third one is security and user access. Log user access login attempt, and whether it is successful or fail. These are useful for monitoring user behavior and include username and timestamp. And lastly, I will talk about disk and storage alert. It report warning like disk space, like this space usage exceeded 80%, which is often with high severity. This log help in monitoring system health. Although we couldn't analyze external traffic, this internal log will still give us valuable insight into SEM performance, system monitoring, and also basic security tracking. Alright, that's all from me. Thank you.
Hi, my name is Mohamad Izzuddin, and now I will be presenting about the logs and events that has occurred or, or has been found during our time of making this project. In this section, we'll explain how the SEM handle and display the logs through three main features, that is live events, historical logs, and also the dashboard. So for the live events tab, this tab shows real-time logs generated by the SEM itself. Since we were using the trial version, we couldn't receive logs from external devices such as routers. Still, we observe some important internal activities such as disk usage alerts, such as Q2 at 42% full. And then we also have found command task logs indicating configuration checks and successful command executions. And then we also found connection failures that the SEM tried to connect to the threat intelligence feeds but failed due to network restrictions. For the second one, that is the main features is historical logs. We also viewed historical logs over a specific time period in a bar graph format. This graph showed spikes at a certain time, likely when the disk checks or configuration tasks has occurred. Most of these were internal audit events, meaning they were system self-checks or integrity events. This has helped us a lot in understanding how the SEM track patterns over time. So for the third and last one is the dashboard overview. It gives us a summary of log activities, a such as the graph showed all events in the last 12 hours, helping visualize spikes in activity. And we can also change the settings of what we want to see. And then the user logon activity shows 9 logins, mostly by one user, probably during the admin testing. The next one is logon failure that also appeared, which may suggest the login testing have failed or have some error. And then the last one is a pie chart showed over 400 events occurred, which most categorized is under internal activity like internal audit event and internal warning. So the dashboard made it easier to see what was happening in the system at just a glance. So overall, these three features has helped us a lot in understanding how SIEM tools like the SEM collect and organize visual logs to support monitoring and security management. That's all from me. Thank you.
Okay, now I will be presenting the key findings from our ESM implementation project. This project involved building a partial enterprise security management architecture using Gen S3 and SolarWinds SEM. To begin with, we designed a virtualized network that include 3 Cisco router and a SolarWinds SEM appliance. All devices were configured and connected through Gen S3 and Hyper-V using proper addressing, subnetting, and routing to ensure successful communication. We confirmed that our network topology was functioning correctly by performing ping tests and route verification between the devices and the SEM appliance. However, as we progress, we encountered a significant limitation, which is the SEM trial version does not support the syslog messages from external source, such as routers, and unless it is a full license is applied. This meant that although our routers were properly configured to send logs, the SEM appliance didn't process them. Despite that, we were still able to analyze and understand how SEM managed log internally. We explored the SEM dashboard and monitored various built-in system logs. These include service status updates, login events, system tasks, and health alerts such as disk spike warnings. We also discovered that connector profiles in SEM play a vital role even though we couldn't use them for external log collection. We saw how these profiles are used to categorize and tag different types of logs, helping to organize even with the CM platform. Overall, this project helped us gain hands-on experience in setting up a virtual security monitoring environment, understanding the flow of log data, and learning how CM platform process and present security information. It also taught us an important lesson when using limited or trial version of enterprise tools. It's crucial to plan for any software or licensing restrictions in advance. Thank you.
Assalamualaikum, my name is Mohamad Aniq and I will present about the conclusion. So this project was successful in demonstrating we implement the enterprise security management, which we use tools like Hyper-V, JNS3, SolarWinds log and event management as our LEM, and we also set up a test that is capable in emulating log collection virtually, real-time event notification, and internal system debugging. We also have some limitation, which is the SolarWinds we use was in trial version. So in terms of external syslog input, event logs
internal provided essentially insight into the how SIEM system categorize, process, and display security related data were prevented as it is limited in trial version. However, we were able to show the disk-based warning event, login attempts, configuration events, and we able to monitor it and show it graphically using the LAM. So this will be confirming the SM platform perform as intended when tracking internal system health and user activity. And one of the primary lesson that we can learn from doing this project is the importance of proper system integration and connector configuration in the SIM deployments. The hence work on the reinforce our understanding of how ESM architecture operates in actual deployments, such as software constraint and network design issue, is one of the lesson that we cannot forget and will be most important to us. Overall, this project provided first exposure to the design, deployment, and testing of an SM system. So we learn a lot from doing this system, and it will emphasize the significance of log analysis in threat detection and brought forward the benefits of using simulation platform for gaining real world cybersecurity skill. So that's all from our group. Thank you.